In this video, we're going to discuss what's called the current divider circuit. And that is just whenever you have two resistors in parallel and you know the current that is entering that node. Now, a lot of times in this case, you will have a current source over here. So that's how you know the current that's coming into that node. But you don't have to. You could even have a voltage source here, and somehow you've solved for the current going in there. But regardless, anytime you have a situation where you have two parallel resistors, you can use the following rule to calculate the current in each one of them. So the current divider says that if you want to find the current through one of the resistors, you're going to take the total incoming current, you're going to multiply it by the other resistor, and divide by the sum of the two resistances. Similarly, if you want to find the current in the second resistor, you take the overall total current, multiply it by the value of the other resistor, and divide by the sum. The reason why it works out this way is if you go ahead and combine these two resistors into a single one using the parallel rule, you'd have R1 times R2 over R1 plus R2, and we know we have our current I coming in. Well, in that case, you can calculate the voltage across that would be I times R1 R2 over R1 plus R2. And since these are the same 2 points on the original circuit, and we now know the total voltage here, as we said before, with equivalent circuits, anything outside of the box is the same. So since these right here are outside of the part I converted, you're going to have the same voltage across them of I R1 R2 over R1 plus R2. And once you know the voltage across there, it's the same across each resistor because they're in parallel. And so if you know the voltage, you can find the current by dividing by the resistances. And if you take this voltage and you divide by the first resistance, you get this formula right here. And if you divide it by the second resistance, you get the other one, and there you go. Now it seems like this may be not the craziest rule ever because all it works is when you have these two resistors and you know the current coming in. But the thing is, you can have all sorts of other things going on in the circuit. Just anytime you have a situation where you have two parallel resistors, you can use this to find the individual currents. So yes, even though this circuit is fairly simple, this can be part of a larger circuit and this rule will still apply.